You can also take the inverse general hyperbolic stretch transformation. It does the exact opposite of the other one. You can see here now it stretches downwards and we're stretching in the other direction. There are certain situations where this is useful, but in most situations, I would not recommend you to stretch backwards. If you stretch up and down, you lose a little bit of data every time you stretch it, so you don't want to necessarily stretching back and forth all the time. Now you have another one here called the modified arc sine transformation. It is basically the same. You can see we have our stretch factor, we have our symmetry points, we have our shadow and a highlight protect. We don't have the stretch intensity because now it just follows a arc sine curve. And the final one is the linear stretch BP shift. The BP is black point. If we put this in, we just have a single slider. And all we really do is just say we move that black point further up. So if I do this, you can see the whole thing just slides backwards and it just lowers the black point a little bit. It's quite common if you're not careful that as you're stretching, this peak will just move further and further to the right, and sometimes it ends up like out here and everything looks like over bright and over washed out because your black point is now too far away from your actual data.